Tonight you'll be speaking about neurography, which is a term that Mario has used to describe his process of working with neural networks. He creates cameraless photography by training neural networks on a variety of sources, including photographs from electron microscopes, machine parts, and Instagram. Need more beer. Once set up, his systems autonomously generate his images, producing up to 5,000 images per night and beyond. With Klingemann, understood alternatively as author, teacher, curator, or editor. And you can see some of these experiments on the media wall as you enter the building, and he'll be uploading more experiments as the weeks progress, or yes. We'll see, yeah? Over the weekend, yes. Mario will be talking tonight for approximately 40 minutes, followed by a discussion with artist and writer Daniel Rourke for 20 minutes, after which point we'll open up to you guys for your questions. So please help yourself to a beer at any point, and thanks very much, Mario. Please take it away.
And thank you all for coming. Wow. It's full, wow. I have to get nervous now. Yes, so as we heard, the talk is called Neurography, 2 years in latent space. Wow, that sounds strange. Yes, so this is not a photography. This is an image that has been entirely generated by a neural network, so it never saw a camera in that aspect. So this as well, and this one, which some of those series you saw downstairs. So yes, I call this technique of generating these types of images without cameras, but with neural networks, neurography. I mean, there is already neurography in medicine, but I just like the term because it's kind of this combination between neurons and photography that somehow come together. Why that is, I explain a bit later. And yes, I want to tell you a bit like how I got into this within only the last 2 years, because that is kind of the time this stuff is possible only. So it's a very young technique. And yes, all of this is only kind of possible because of so-called deep learning, or as the press always likes to call it, AI. I hate that term because yes, I think AI will be something different, but it's of course nice to like have a short term that you can like refer to. So yes, I'm the AI artist, even though I don't feel comfortable about it. And deep learning originally was invented to turn cats into data. So that is kind of the original purpose. So, and it's not totally true, and actually it is to turn pictures of cats into data. So, and if you have a digital image, it is actually already data, because every pixel in an image is like, if you take color photography, has a red, green, and blue value, and then you could take the coordinate of it within the picture, which is an X and Y. So for every pixel you have 5 data points, and then you have, I don't know, 1 million of them. So every image is already something like a huge spreadsheet that you could load in Excel. But then, yeah, the problem is it is way too much data. And deep learning, pretty much all it does is try to turn all these kind of millions of data points into something it can deal with and can try to extract some meaning. And in order to achieve that, we use so-called neural networks, or like if we want to see if there's a cat on an image, we use a convolutional neural network, or a CNN short. So what you do is you throw in a cat picture at the top, and then it gets processed through several layers, and in the end the model tells you, oh yeah, there's a cat on it or not, or a dog. Well, if you look inside of one of those convolutional neural networks, it's actually cats all the way down, or pixels all the way down. Because pretty much what it does, it applies kind of weird Photoshop filters which condense in every step the image further down. And like this is kind of on the left is the first step of analyzing an image. And what you can see, it already tries to figure out certain aspects of the image, like where are the edges? Is there a certain kind of texture? Are there certain colors present in this image? And it passes on this information to the next layer, which then again looks and combines certain things it has found there. Like, oh, there are 3 points in a row, that must be an edge. Or then several edges in a deeper layer might become something where it recognizes a circle. And the lower it goes, maybe at some point it learns that a circle is actually an eye. And deeper even, then if something has 2 eyes and fur, then it must be a cat or a dog. And so that is pretty much kind of the principle these neural networks all work. There's something very interesting happening inside, and that is something I use a lot, or which makes them so interesting, that, as I said, initially when the image gets passed in, there's all these superficial information that tells you something about textures and surface stuff. But the deeper it goes, the more the information gets abstract and actually into meaning or content, where like what first is just some texture, at some point it becomes fur or it becomes an eye. So the deeper layers of the network tell the model something about what is actually on there. And just before the model is able to tell you it's a cat or a dog, it produces something that is called a feature vector. And sorry for the technical terms, but the feature vector is actually the most important part. Because what the feature vector is in the end just a bunch of numbers. Again, like an Excel spreadsheet. Let's say 128 numbers. But these numbers are actually a coordinate in a multidimensional space. And what happens is, when you train the model on, let's say, trying to distinguish cats from dogs, from cars, from mobile phones, this feature vector tries to move the objects that it has detected in this multidimensional space in such a way that it can easily make cuts between them. And so that, for example, all the dogs try to end up somewhere here, the cats in a different area, and the cars maybe somewhere here. And then the model can easily say, everything that's in this area is very probable a dog, and this is a cat. Because we cannot think in multidimensional spaces, there are techniques that allow us to visualize how the model has interpreted the world based on the training data. And there is something called t-SNE, which is a very popular data visualization technique. And so once you train the model and feed it with lots of images, you get these, well, it's almost looking like a map of an unknown country. And what actually happens then is that lots of cats will land up in one area, and I don't know, the dogs might be living up there. Problem is, it's a multidimensional space that gets twisted, so there are also cats here. Maybe these are photos of cats, these are illustrations of cats, and these are people wearing cat costumes or something like that. So it's this kind of map is well a way for us trying to understand this world, but in the end, this so-called latent space that this model builds up based on what we trained it on is extremely abstract, and so we just kind of get a shadow on the wall of what it might be like. But, well, another example how I like to explain how what these models do is kind of your laundry. So, well, when you put all your laundry in the laundry machine and then you pull it out, well, everything is twisted and thrown together. And that is kind of like the data, you could imagine. What the model does is tries to untwist that data and separate the socks from the knickers and the t-shirts. And in a way, that's what you do too, right? You take it out of the laundry machine and then you put it into your drawers. And yes, so then there are the t-shirts in the top drawer, in the middle drawer, I don't know, the socks and then the knickers. So I don't know. So, and that makes it very easily to just make a cut, and you can say, okay, I want to go out, so let's pull out the top drawer. And so this is pretty much all the model does. So what can this be used for? Well, one thing is that because every object in this space has a defined coordinate, you can start making measurements in there and ask, for example, how similar is this image to that image? And you can get actually a number. So, and images that are very similar, that show similar objects, will have a small number because it's really like geometry, like a short line between them. And well, I, for example, use this to analyze movies and say, oh, this is a scene of a hand. Find me all the other scenes that show hands in this movie by like taking all the feature vectors of the frames and then taking the ones that, well, look similar to one scene I already found. So yeah, this was just a simple experiment where I downloaded some movies from the Internet Archive, and yeah, but it works really well because the thing is, everything else looks very different, and I can always tell the model, give me more of this and give me less of, I don't know, portraits and things. Or the same stuff works with photography, like with typography. Once I've trained the model in saying like, there is type on this image, so remember that coordinate in this space, and there's type on that, then it can actually, well, it doesn't know what type is, but it knows that it finds typography in a certain, like, space in this latent, like in a certain area in that latent space.
Young lady who calls herself
and so on. One thing where I also use these kind of feature vector distances is a commission I got by Google Arts and Culture. It's called X degrees of separation. At Google Arts and Culture, there is this huge database of cultural artifacts. It's actually millions of them, but so there's a section of, let's say, fine art, sculpture, ceramics, so everything kind of like objects and artifacts. And once you have, I don't know, 500,000 objects that you could potentially search, the question is always, where do you start? Like, what are you actually looking for? How do you find anything in there? And what you usually do is you start by, well, something you know. Maybe a painting by Van Gogh, or, I don't know, a sculpture by Degas. And I want also discover things that I might not know about. So what X degrees of separation does is kind of like 6 degrees of separation, this theory where every human is connected to every other human on the planet by just 6 steps. Like, I know somebody who's a friend of this person, and over 6 steps I end up with, I don't know, somebody who makes dim sum somewhere in Shanghai or so. So there's actually a mathematical number that it never takes more than 6 steps. And so the question is like, can I make these connections between artworks? And by using the feature vector, I can say, how do I get from, well, this is how the installation looks. How do I get from this painting on the left to this sculpture on the right? And what you can see, the machine doesn't know anything about the artworks. It just takes the feature vectors and starts, well, it actually is like the navigator in your car. So how do I get from London to, well, I don't know, from here to London Heathrow? It tells you, oh, take this street and then this next corner. And the same way it works in this latent space. So it kind of looks, how do I get from this artwork to that? And then it looks for the nearest feature vector that it can step to. But it does this in this multidimensional space, how the machine has understood to read images. So it has learned about, I don't know, faces, about colors, about textures. And well, you can definitely see there is some gradient and logic going on. It's definitely not a logic a human would make, but that is what I find interesting, because along the way you have the chance to discover things that you were not even looking for, but that you still might like. Maybe some unknown artist or some technique, something that you wouldn't even go to in the museum because you think, oh, it's a boring department. So yeah, again, so this stays, for example, in the blue space, but we go from a ceramic to glass, or again, so. The interesting thing, so it never steps out of the face space here, for example. So because, yes, so it has some concept about faces, well, but on the other hand, it also really values a background of an image just as high as the foreground. So it does not have a concept like us that would, for example, ignore the gray background on the left and just focus on the center. So it first tries to fix the background color too, to get to this more beige space. And one last one. So, but yeah, so this is kind of like for the model, it doesn't matter what images you feed in. Everything has a feature vector. Everything is kind of like somehow logical in this space, and which is kind of why I like this latent space so much. So before you can actually work with these models, one thing you have to do, or well, you should do, is you have to train the model. You have to kind of tell it what you are looking for or what it should do. And the problem with training is that you have to give it lots of examples. I mean, we are not talking about hundreds, but we are talking about 10,000s or maybe 100,000. So the more images, the more examples you give the model, the better it will get. Otherwise, it might just kind of overfit and kind of give you the illusion it had learned something, but in the end, well, it will not really generalize well. So one thing I tried, for example, was if I could train a model that could distinguish decorative initials. These are from the British Library collection. So, well, you all know OCR, like text recognition, but that usually only works with like clear type, things that is logical. These are all kind of crazy and different. And so I had this set of about 60,000 different like decorative initials. Problem was first that, actually I had sorted them kind of already, because that was a half manual process. But in order to do that, I had to build me a little tool. So the way you do it is I start with just a few images, like 10 A's, 10 B's, 10 C's, and train the model. It's not really good. It's kind of doing, well, not a good job, but it's better than random. So, and then after I trained it for, I don't know, a few hours, I ask it, okay, here's an image, tell me what you think, what letter it is. And then the model says, oh, I think it's an A, I think it's an B. But at that point of training, you still have to kind of confirm or deny that it was correct. And for that purpose, I built me this Tinder-style tool where it says, I think this is an A, and then I swipe left and say, nope, this is something else, or I swipe right. And so with this approach, you can go through 2,000 images or so in 1 hour, and that way, actually, within one day, you have created your own training set. And then you just go and train the model. I mean, I will not explain you like exactly how to do that. You go to GitHub and download frameworks, and that would not kind of like, we're not talking about programming here. It's actually not that hard, but at the end or later, I can give you some links how you can actually go into the nitty-gritty stuff. Right now, this is really more on a higher level. So in the end, I had a model, and it works really well. Yeah, so it figured out all the A's and B's, and then it gives me something like this, where it says, hey, it's a B. And I say, oh, no, this is a ruin. I don't think so. But, well, the nice thing about this was also from the British Library, or was it Internet Archive? No, British Library. So what you can do, you go to Flickr, and then it will actually tell you from which page of the book this thing came. You can click, and then you can open up the entire page. And damn, it was better than me. So it was actually a B. So this is, of course, where it's getting interesting, that the model starts getting kind of better than myself, or at least confident. But it gets too good, because in the end, all the model knows is that the whole world is made of letters, because it has no other concept about this. So it sees letters in every object I show it. So yes, it says this is an F, an A, an I, and an L, even though it's probably not meant to be. But this is where the beautiful kind of inspirational part starts, because then, of course, I start collecting all these false recognitions. So this is everything where the model said it's an A. So quite nice. Or an M and T's. So yeah, so this allows you to kind of like, well, have the model inspire you for other things. But okay, so this was all the classification part. But of course, we want to hear about how do I generate with this. So as I said before, I call this process of generating with neural networks neurography. And because in a way, I tried to give you this idea of this latent space. And in a way, I can go inside that latent space that a model has generated and say, tell me how it looks at this coordinate. And then the model will give me back a picture. And in that aspect, I feel like I'm like a photographer that kind of frames this world that I made. And I try to find the best spots or the best framings where I find the most interesting pictures. So how does this all start, like the ability to generate with neural networks? Well, it was actually a bit more than 2 years ago, 2.5 years ago, with Deep Dream. And you probably all have heard that. Deep Dream is this psychedelic technique developed by Google engineers that when you saw it the first time, you, like me, probably thought like, whoa, this is crazy, like what kind of drugs are these people? And then probably like 3 months later, you said, oh no, don't want to see it anymore. But the beauty about Deep Dream was, maybe somebody does not know how Deep Dream works, so I quickly explain it. So Deep Dream works like you start with an image, you feed it into this kind of classification network that I showed you before, and in the end, at some layer, you say, well, now with what you think you see there, go back and emphasize anything that you believe you see in this image. So if a little black spot, you think it's an eye, make it more look like an eye. So it feeds it back up, and that's what then happens. So this was actually a model trained on, well, actually there was this problem that initially Deep Dream came with a pre-trained model that you could download, and everybody did that, like the people who download the frameworks. This model had the problem that it was specialized, it was a generalized model that could do the mobile phone, house, car thing, but it was also specialized on detecting puppies or dogs. So it knew 100 different dog breeds. And slugs. And that is kind of, maybe you have heard the term puppy slug, because that's what it always generated. There's not a puppy slug there. I kicked it out. But that's the problem. So all the images always turned up eyes and fur and slugs, because the problem was that model. That's all the model knew. And so the first thing I tried was trying to kind of control that model more, for example, force it to do a certain category. So you see, I tried to enforce the puppy category on this one, or I trained it on my own models, I trained my own model. In this case, it was trained on record covers. And as it happened, there was this heavy metal category, which has all these skulls in there. So it turned every face into a skull. So that was kind of nice. But it was still kind of going all over the place. So like in some part it saw a dog or a skull, but I wanted to control it a bit more. So I tried this technique I call deep lobotomy, where, when the model goes down and activates certain neurons, what I do is I just say, turn everything off, but keep only these ones on, which means that in the end, when it feeds it back up, it just emphasizes a certain strange category it has learned. And then what you get is these kind of texture images. So in a way, this is some kind of texture the model needs to understand certain parts of an image. But if I just keep that one on, it starts generating these proto-textures, which are broccoli. There's lots of broccoli in there. This is already quite interesting because, it might be an electron microscopic imagery or so. But there was always this kind of issue with the psychedelic colors. So fortunately, technology kept evolving. Oh, more, So the next thing that came out was a technique called plug-and-play generative networks, or this paper by these fantastic scientists, because that is the next thing that I have to tell you. I don't invent these technologies. I'm just profiting from the hard work of fantastic scientists that share their papers, share their research, and ideally share their code. So in this case, and that is kind of like mostly what I do. I follow scientists on Twitter and try to find out who is working on the latest stuff, and then is this something I can use in my art? So this was the paper, and it's kind of like Deep Dream, but not exactly. What this thing does is, it takes noise, and then tries to evolve that noise so it fits more like a certain, becomes more like a certain category. So it doesn't really do this feedback loop, but it says, okay, if I change this pixel a little bit, it looks more like an apple, or it looks like more like a cat, and it repeats that and repeats that. But what I did here was to say, well, don't go too concrete, just stay in a more abstract level. And so in this case, well, you get all these kind of weird abstract imagery that seems to be some shapes where you might recognize something, but well, I like it because it's actually not as concrete. So some of these things might look like some painting, but in the end, it's just starting with some noise, and I say go to some random category and try to improve it as much so whatever unknown category 5 becomes the most dominant category here. Actually, there's a second process involved, making these images big, but I will come to that in a bit. So this was nice because it was allowing me to explore this latent space. Because in the end, what it happens is I go in this latent space and say, how does it look here? Like, what is this like? And then it tells me, yeah, this looks like this, I don't know, black island floating in white space. Oh yeah, there's this other technique. I fear I have to mention it, but I'm kind of like hesitant to do it. You might have heard about this. It's called style transfer. It's another one of these techniques that you can do with neural networks. If you remember that slide I showed earlier about this part where initially the model recognizes kind of stylistic elements, and later on in the image it learns about the content of an image. Well, what this style transfer can do is it can take two images, analyze them, and it gets the style component and the content component, and then it can interchange them and say, keep the content of this image, but apply the style of that image. And then you get this, oh, make your photo look like it's painted by Van Gogh. And sorry, I hate that. It's really like, and it has become such a cliche, but I have been using it too. So this is some kind of, I took some kind of painting actually and applied it to some other image I generated. So, well, it's interesting and different. The problem is, after a while, I feel always every style transfer image looks like another. So there is something like a certain style transfer look. Yeah, so this is again a generated face, and then there's these elements. But it's interesting, and it has its uses, but right now it's a very overused effect. But yes, so models allow you now to exchange these styles, but I try to stay clear of this in a way, because this is what the cool stuff is. So, and you have to remember that probably, maybe you have heard about it, it's called GANs, or Generative Adversarial Networks. And this is kind of the best that was invented actually pretty much like a year ago, or a little more over a year. You might have heard of Pix2Pix, because Pix2Pix is a GAN. And, well, this is not by me, but this was very popular. So the way it works, you feed one image in this case, this scribble of a cat, and then the model will generate the image on the right, which is a photo of a cat, because it has been trained on these pairs of images. So the beauty of Pix2Pix is, well, the model learns to transform one representation of an image into another one. So, and the representation on the input is usually something very simple and abstract. So it could be a scribble, it could be a kind of a so-called semantic map where, I don't know, maybe a yellow spot stands for, well, I don't know, a house, a green spot for a tree. And so then the model will try to transform this into the other. And the way these generative adversarial networks work is really fascinating. I quickly explained it, so I tried to explain it. So it's actually two neural networks playing against each other. One is the so-called generator, or forger maybe, and the other is the discriminator, or a judge. And like, if you imagine this, like, let's say on the paper example, so the forger tries to fake paintings that look like Picasso paintings. So it starts painting them, and then Well, it throws it in a box. In the box, there are also real Picasso paintings. Well, the judge or the discriminator takes out a painting, looks at it, and says, this is a fake, and then turns it around, and then you read, oh, it's a fake, yes. So the discriminator was right. So it tells the generator, oh, I caught you, you must get better. You have to learn. And the nice thing is it even tells it where it went wrong. Problem is initially the discriminator also has no idea about art or anything. So both start very stupid. At the same time, it sometimes might pick out a painting and say, oh yeah, this is a real Picasso, turns it around, and it's actually a fake. So in that case, the discriminator looks at the painting and says, oh, where did I go wrong? So it learns also. So both of these models get better and better in one gets better at faking and the other gets better at detecting fakes. And in this kind of feedback loop, at some point, they get so good at generating images that we, as the discriminators, are not good enough anymore to distinguish them from real images. And that is kind of that dangerous, slippery slope that we are currently on, right, with all the fake images and things. But this whole concept of the GAN is brilliant because it cannot only work with images, it can work with text, it can work with sound, and well, I don't know, and maybe even in social life. So I'm always wondering if, I don't know, well, I might come to that later. No, so taking otherwise too long. Okay, but so I started playing with these GAN techniques. Well, once they came out, because I found them so fascinating. And the first thing I wanted to know is, can I do this magic enhance effect like they do in the movies, right? Where you have kind of a blurry picture on the left, and then in the end it will tell you, oh, this is kind of the culprit, or this kid stole the apple, or I don't know, on TV. So in the movies it always looks so easy. So, well, the way you do it is you train the model on pairs. You give it a blurry image, and you give it a sharp image, and you give it thousands of them. And then it will try to learn how to reconstruct something. It's given a blurry image, and it should give you an output. And this is what comes out. So this is, for example, the input. And this is then what the image has, the neural network has generated out of it. Not really a photo, but definitely very interesting. I mean, it looks like art, doesn't it? I mean, it has all these beautiful artifacts. So, of course, well, I liked it a lot. And so if you have kind of more core structures, it actually gets close to it. Well, but still, in the end, it's not really enhancement that it does, but it's transhancement. So, because it transforms the image and enhances it. But it's not like a filter. I mean, the most interesting thing in all this working with neural networks is that the model or the neural network actually adds information to the image. So when you blur an image, information gets lost, or at least it gets very kind of distributed over all the pixels. I mean, it's not truly lost. So, but so the model actually invents new pixels or new information. It's not just kind of distorting it together. Based on what it has learned about the world, by seeing lots of pictures, it is actually able to reconstruct an edge or to create an eye at a certain point where, and that is the fascinating thing. So there's actually information coming in. So, but yes, enhancement didn't really work, but I liked the artifacts. So I applied this to photos I found on the internet, yes, and it definitely gives you this kind of zombie look. But, well, when I saw these, I thought oh wow, this is definitely something I haven't seen that way. And that is what I'm always in for. That's why I'm doing this, working with images, because I want to see images I haven't seen yet. So definitely there is a certain kind of look about them. There are typical artifacts it generates. But, well, the beautiful thing is I can zoom in, and it creates all this kind of, this was the eye, and now it has all these interesting structures happening. And yeah, and so I didn't draw them. It's kind of the model makes them up. I can only try to shape the way the model does them by picking the right training data and setting the right temperatures and the time, like how long do I train a model. So this is then where the art starts, I guess. So yes, the model does the work, but I still have to select kind of what it should do. And so I have this, I can try to steer it in a certain direction, but I have not full control. I always see it like, like a musical instrument maybe. So, well, it's kind of, you find this thing and it seems to be a musical instrument, so you start plucking or hammering it, and then at some point you learn, oh yeah, this is how I actually play it, and then at some point you can start making melodies. So this is the way I work with these neural networks. So, yes, so there are some more details, and yes, I really like those artifacts that it makes. It's really creating these different things. But at the moment, yes, it's all kind of found photos. So I love the Internet Archive. There are millions of old scanned-in portraits and photos, and they are all public domains. So I take them and transform it. So this is Mr. Catface. I really like that guy. So but there is something, yes. So there's this problem, like it's very easy to do creepy, and it's very, very hard to do beautiful. But so right now, unfortunately, I'm still in this creep space, and it will get worse. I mean, you will see. Yeah. So, okay, but the pix-to-pix stuff is not finished yet, because yes, this model is so versatile, because the principle is you feed some image in and something out. You can apply it to lots of things. So I thought, like, okay. So far, I use photos as a base, but I really want to generate the photos fully from scratch. But I don't want to do just the abstract things like in the initial one. I want to, like, well, humans like to look at humans. So, and the human form is, of course, a classic in art. So I thought, like, can I generate human form by just starting with stick figures? So I used another model, and actually a pre-trained one, that I can give a photo, and it will extract me a stick figure from it. So if there's a person standing on it, it will tell me, okay, here's the upper arm, here's the head. And so I get actually a little stick figure model out of the photo. And then I give it, again, I don't know, 50,000 photos, and it learns, in a way, how do humans move and stand. And so once I have these 50,000 different poses, I can just interpolate through this pose space. So actually, what looks like an animation is actually just the model interpolating through random poses. So it's not taken from a video. So yeah, I thought, oh, you just saw that, where it looks like it was dancing. So the first thing I tried was just like, let's see if I can make a little dance video. So, oh, this is a little, okay, so. But yeah, so what happens here is I analyze the music with a neural network, or not really, yes, so I'm trying to find beats and certain similar phrases in the song, and whenever the model hears something, it tells the figures to change their position. And so in the end it looks like dancing, but all it does is it kind of flies through pose space. And but we don't see the whole thing. So. But of course, the next thing I wanted to do is use these stick figures to generate something that looks like photos or paintings. So again, I use pix-to-pix. I train it on an original photo that shows kind of like shows a person, and the input is a stick figure that the other model has extracted. And when I do that with, I don't know, 50,000 images, I can then give the model a stick figure like the one on the left, and it will output me something like this. So this is actually, so yeah, obviously not a photo, but it looks strange and interesting. And so actually you can see that I used selfies maybe as my training set, because, well, yeah, so it knows about mirror selfies. But it also creates these things. So in the end, I just picked a random pose, or I had the model make me some random pose, and then it will output me something, and I have to go through hundreds of thousands of images and pick the ones that I found interesting. So this is from the solitary confinement series. So because there's this weird thing happening that there's always, like in lots of these images, there's something that looks like me, like a prison cell window, and then there you have this child in a pink pajama. I don't know. Well, that's what I see. Again, that's what I find interesting about them. That, well, maybe you see something else. Maybe you see somebody in an evening dress or so. But I like that these images are so kind of not concrete in what they show, and that you can make up your own story. So there are a few more. So all of these are pose in, give me an image. And well, it has kind of, sometimes it's more abstract. I don't know, some black lightning strikes somebody. This looks to me like a cover for some pulp novel, maybe. I don't know. Well, there's, well, up in the corner could be the text. And yes, so this kind of looks like Dali or something. I don't know. I see Dali there. There's always, that's a problem right now. I post something and it's either looking like Francis Bacon or Dali, or, I mean, I'm collecting all the artists that my work looks like now. So, but yeah, so that is then where my kind of the nice work starts. So once I train the model, I just kind of let it run, and in the morning I come with a folder full of images and go through them, and well, admittedly, 95% are not interesting. Well, and there's the other problem. Initially, when you have a new model, or for you maybe, well, most of this looks very new. Once you start looking at 10,000 of them, you start learning how to see them and how to read them, and you get, well, you start seeing the errors, and you're getting bored, and well, I do. So I want to move on to the next model or to something else, or try to make it give me different colors or better textures. But so it's interesting that you actually have to learn how to read these images, and of course, there's something about being good, is that it's not common. So if you have 10,000 good images, that it will not work, because the point of something being interesting is that it's rare and not common. So so initially you might think 500 of them are great, but like you come back 2 weeks later and you realize maybe only 2 or 3 are. So these models, well, could theoretically sort them out, but okay. Okay, this is one of those where people say, oh, looks like Francis Bacon or so. But again, it's just pose to picture. And this is from a project I did with Albert Bark Duran, a painter, which is called My Artificial Muse, where he wanted to see if he, as a painter, can be inspired by the machine. So the machine generated these poses from pictures, pictures from poses, and in the end, he, in a performance, started painting this in oil on canvas. So, and it was exhausting for him, because because also there are all these artifacts it generates, which are not like painting artifacts, so you have to wonder, do I stay true to painting or to the artifacts that the machine has generated? What is the proper way to translate something this digital back into analog space? So. Well, next, after the bodies, I thought, okay, well, the human face is, of course, also a super fascinating topic, because we are all experts in faces, and faces contain so much information. Like, we look at a face and we immediately kind of like start making up stories or explanations. Oh, why is this person looking like this? So I wanted to generate faces. So again, I can use the same principle. There are neural networks that are able to give you the biometric data of a face, so which is kind of what it looks on the left. So I give it a photo, or in this case, a sketch, like an engraving from the British Library, and it extracts me first those face markers, and then I can start training it, and well, in the end, I can go and say, make me a face. Based on what you learned. And so on the right, these were already faces that the model had generated. It can also go almost photorealistic if you train it on photos. I mean, there's this thing right now, I actually don't want to go photorealistic, but I think I first have to try to get photorealistic in order to later say, I can do it, and I can always kind of dial it down again. But if I can only create kind of half good faces, well, then I kind of got stuck. So, so if you've seen, maybe there was some, NVIDIA, for example, had this paper out recently where they really almost got photorealistic. So right now, so this is more for me a proof that I'm almost there, but it's not something I would call my art. It's more like, oh, I can do it. This is much more interesting then, because I can take 2 models. Because what I can do is, I can take this face marker model, so it's saying, I give you face markers, make me a face, but I can also turn it around. I can say, here's a face, make me face markers. So that's kind of I'm doing the work of the other model that I used initially, but then I can couple these 2 models together. I can say, here's some noise. See if you find any faces in it. And then it feeds that to the other model. So it tries to generate face markers from noise, passes it on to the model that creates faces from face markers. But then that model passes the face it has generated back to the face marker detection model. So you have this feedback loop. And what initially is noise gives you, again, this kind of deep dream effect where at some point, something like an eye it's actually seeing an eye there. And then the eye starts growing, and then the other eye comes, and the nose. So in the end, all these faces are, well, I didn't even start with a face. It starts doing this kind of like face soup just by having this feedback loop between two models. And as you can see, it's kind of these proto-faces, because there are different ways you can train the model. And in this case, I like the proto-faces because they are so clean, but they are kind of more as a mold for other models that might follow. Oh yeah, for example, this one where I trained another model which takes pairs of, well, human faces and doll faces, and it learns how to transform human faces into doll faces. So this is actually a model called cycle GAN, which is kind of more comfortable because you don't have to do pairs anymore. You don't have to say everything that on this image becomes that. But you just say, here's a folder with doll images, here's a folder with selfies, try to learn something from it. And so in the end, so it learns, oh yeah, dolls have big eyes, and kind of like the proportions of the face get squished. And so what I did is the previous model with generate the faces was then fed into this doll face model and transforms it again. Oh yeah, and then you can go and do weird stuff like turning off the eyes or taking face markers and making faces move their mouth or rotate them. So in the end, I have this model that allows me to kind of just see what happens when like little sock dolls. I can just start making. So these are not any kind of real faces, as you realize. Okay, and this was made together with David Kemp, who made the music for me, and then I fed the music into the model and let it just run. That's what I like. I don't like to edit. I just like I'm lazy. So I say, okay, model, look at the music and kind of like make things move. So, no, yeah, okay. So and then there was this other project, yes, called, so because, well, it was also pretty much a year ago when, Kelly and Conway said this horrible term, alternative facts, in this interview that kind of, oh yeah, there have been alternative facts, and that this whole kind of, I mean, usually I'm not kind of like diving into politics, but this was kind of like, oh no, so actually now we have reached this age where we have used newspeak. If you combine that with like lying is now actually totally like okay, it seems. So if you combine this with the possibilities I see that we can lie with images very convincingly very soon, what might that take us to? And so I made this alternative face thing where I had a model, my face model, which I had trained on the French singer Françoise Hardy, because there's this thing about the model. So if I train a model only on photos of people smiling or looking regular, and you try to make it really move, it might have never seen somebody like open a mouth. So it will never be able to create an open mouth. So if you want to have somebody's face move, you have to train it on moving material. So I downloaded all these videos, music videos from Françoise Hardy, and tried to learn her face. And so what is happening in a second is, so I take the face markers of Kelly and Conway and map them and generate a face using this face generation method with what the model has learned how Françoise Hardy looks.
Answer the question of why the
and I
president
add some
asked
random
the White House press
camera
secretary
motions. So it looks really like a bad mobile video. But it's not face transfer or
Why did he do
deep
that?
face.
It undermines the credibility of the entire White House press office
No,
on
it
day
doesn't. Don't be so overly dramatic about it, Chuck. You're saying it's a falsehood, and they're giving Sean Spicer, our press secretary, gave alternative facts to that. But the point remains.
Wait a minute. Alternative
that there's-
facts? Alternative facts. 4 of the 5 facts.
Well, you can see some
Hey,
interesting
Chuck,
things
why-
there
why
because
Chuck-
I trained it on multiple
Facts here,
videos.
it's not true.
It still kicks into
Alternative
like,
facts are not
you see how
facts.
her face morphs
They're falsehoods.
because somehow at some certain poses of the face, it kind of thinks, oh, this is closer and that. But in the end, it makes this weird mixture. So it does not really replicate the images. It regenerates them. But it's still kind of like, depending on how your training data looks, it might try to copy what it has learned, especially if you take a single image, like a single person. But so yes, of course now, a year later, people are doing this much better. The technology has advanced, so now this almost looks like, oh my, this is, but yes, things move so fast. So now you have all these deep fake things where people montage faces onto other people, which is actually a different technique. But yeah, so now we have already reached that phase where you cannot really believe, like, know if an image is true or not, like is made up or not. So I have no answer kind of how to deal with that, except for that you have to kind of make up your own circle of trust maybe, or like check twice, try to find independent sources. But yeah, this is an unsolved problem. Okay, last chapter. Now I have these models, all these little GANs. It's like Legos or something. And what I can do is I can really like plug them together. I can say, well, model A, make me something, and then I feed it into the next, and maybe create a feedback loop. And in the end, well, I can explore all these worlds that they generate and kind of try to tune it into certain ways. So, for example, yeah, this is the decay model where I had trained a model on, well, I found this nice, it's the Coinciding archive, I think. Again, public domain on Flickr, in the Flickr Commons collection. And it has beautifully destroyed, decayed glass plate photography from, I don't know, maybe 1900 or earlier. And so I really like photographic decay and all these fungus and cracks and faults. So I tried to train a model on learning these faults. So, and that's what you can see here. So I combined the face generation model with the model that, in a way, all it knows is faults. And if you feed in the face, it will regenerate the face using kind of what it knows. Another one. So, and yeah, so I like all these textures and things. So yeah, it's just, so the face that it uses is kind of made up by the model, and then I can add this layer of style and texture, which adds a whole another dimension again. This is actually trained on an image trained on electron microscopy. So because yeah, I also like the aesthetics of electron microscopy. So and the photo behind it, I think, was actually one of the Internet Archives, maybe transformed. Again, so I can really just play and combine these models together and see what comes out. So again, half-generated portrait run through the electron microscope model, and there's a zoom because now there's this difficulty with resolution, which I half solved now. Usually these models work at a low resolution. So if you have, even with my GPUs that I have, I think we come to that later. So it's the graphics card which does all the work. It can only fit a certain size of image into memory, and especially when training. So if you're happy, then you get a 512 by 512 pixel image that it can generate. So if you want to go big, you have to work in tiles or do things like that. And so this is then what you can get, like, because this is, of course, a few thousand pixels wide, and then it creates really all these interesting structures based on what it knows. And so this is then the electron microscope stuff, but it uses the content. Well, so it's not style transfer. It is kind of, it's a mixture between like where content and style kind of are in this gray area between them. Or it can go entirely different. It's again the electron microscope image, just kind of using textures which are, well, not as crumbly. Or This is an emoji, which is kind of like, I can use this technique also for upscaling. So this is kind of this 16 pixel by 16 pixel emoji. And I just used the neural networks to scale it up and scale it up again. And always using the electron microscope image on it, model on it. And so this is then what comes out, like after, I don't know, 5 steps of enhancement. And so yeah, these are then models I trained on the human body and faces and skin. And the content is actually generated by a feedback loop of 2 models that are not compatible with each other. That is the interesting part. So I can, usually models expect a certain input. Let's say the cat, draw a cat with a sketch and get out a painting of a cat. I can feed in any image in there. I can feed a photo, and the model will try to do something, but it will look very different. And I actually creatively use that. I feed the model with the wrong data, and if you do that in a feedback loop, kind of crazy chaos comes out. But then I can take the crazy chaos and feed it into another model which reinterprets it. And if you do that multiple steps, like the faces that kind of emerge from the noise, the model will, if the model has been trained on human bodies, at some point it will try to make something that looks like a human body. Or, yeah, I don't know. It's a strange world. So this is kind of like these things you find in latent space. So I think I call this Send in the Clowns. So yeah, because I see them as really like Rorschach tests. I don't know, there's kind of a clown, and this is, and yeah, so this is then putting together these models and really like keeping the ones that I find have interesting composition or interesting shadings and structures and textures. And well, again, it's something I haven't seen yet. So I don't know if it's any good, but it looks very different to kind of things I know. And another one from latent space, using the human body model. And Careless Whisper. So yeah, so you see there are elements, but it's kind of like, it's not making a collage. It starts from something like crumbly noise, and over time, kind of like it develops things out of that. It shapes, like it tries desperately to find meaning or content in it and shape it out of it. And well, thank you. Yes.
We can just sit out so people can see. We can just sit and do this.
Now I can have a beer, right?
Thank you.
Oh, that is dangerous, yes. Ta-da-da.
Okay. Lots to take in.
Oh yeah, I don't know. Did I go way over time? I did.
You went a little bit, but it's fine. We're gonna tie this into some larger questions. Maybe get to some of the kind of meat, the politics of this, maybe.
Okay.
And then we'll open it to the audience.
Thank you.
Okay. I'm really taken with the aesthetic of these images, and after seeing so many of them, which is a very rich experience to sit here. I'm kind of projecting into the not too distant future, where a few years ago glitch art and the glitch arts was kind of bubbling online, and then it bubbled out into album covers, and then into Hollywood cinema, and the kind of aesthetic made its way into the mainstream. And I just feel like this is going to become a kind of aesthetic of our time. It's going to be a kind of way of seeing and a way of thinking. So I wonder whether, firstly, with all of your engagement with these kind of images and kind of building a relationship with them, whether you've started to see the world in a different way, the kind of, images out there, not on your computer screen.
Well, I definitely see the world now as a constant source of material, which I like, oh, can I train it on this or that? So, yeah. I mean, in a way, yes, I collect textures, I collect objects or categories, and that is definitely, yeah, but in a way, every photographer does that as well, right? Only that kind of I'm reckless and taking in every. I don't specialize, so I just look at the qualities of certain things and how well it might train. So
You're always looking for the next data set, basically.
yes, kind of the whole world is my data set. So because that's important, right? Like at the moment, I still have to steal the content from the world. I mean, I can now start generating new visuals, but in the end, all the model can work from is some content coming from the outside. But again, my favorite thing is like humans do it as well. I mean, so we can also just work with what we see or hear and transform it. So in that aspect, the models are similar. I definitely think this aesthetic is, of course, going to take be the next glitch art or whatever. And then on the other hand, I also think maybe it will be just a short phase, because right now technology is kind of in the early, this technology is in the early stages, right? We are in the glass plate photography stage now, when you compare it with photography. So, and quality and resolution and these things will rather quickly change. So in the end, maybe if you want to have this kind of weird artifacty look, you will have to go back to the models of 2017, because the new models will just do perfectly. Everything is super HD and looks totally real. And so maybe in 10 years we look back at this time and say, oh yeah, you remember kind of this GAN art. Yeah, these were, and everybody will just be doing kind of super realistic, VR visuals. So on the other hand, well, there might be the artisans that say, oh yeah, I do the 2018 pics to pics. Well, I still have an old machine on which it runs.
I think we know it's in its early days because the first application is always pornography.
Oh yeah.
Any technology that comes along, the first thing is that it gets jumped
I think it's a driving force. I mean.
Yeah. I mean, you go back to the resurgence of VHS cassettes or any kind of medium, the pornography industry kind of drove it. And the headlines at the moment have been around these neural networks which have been used to map celebrity faces onto pornography, and then that captures the headlines and it drives the conversation.
Yeah, I mean, in a way I saw that coming too, and it was just a matter of time until it's kind of point and click. So that is kind of usually, yes, it was bound to happen. It's strange that it only happened now, because this face swapping was technically possible since, 5 or 6 years already. So,
but the difference is that now there are tools readily available that have been given to the
it's commodified.
Google and so forth.
So, well, I mean, these are more like open source things, but yeah. So, it's bound to happen. It's already kind of getting like banned, right? Which is good. So I think, well, I'm not a proponent of that. I think it's more like style transfer, right? I'm more thinking that you should try to generate original content. I mean,
but no, I think there's something interesting in that, and the capacity with which these open source tools have leaked out, and which people are building their own now based off Google's original set. Yeah. And as you say, originally it was just puppies that kind of that manifested in this, and now we're making a whole new array of images. But it seems like even in the infinite possibilities that come from that, and I see this in your images too, that there's certain patterns that emerge.
Yes.
The skin tones are very white and Western. There's a concentration of women's faces rather than men.
Okay, that is my personal bias then. So,
but this is maybe what I'm getting at, and it's also my bias to project my own perceptions and my own image recognition onto what I see, and I start to pick out things that I'm aware of. So this comes to my next question in terms of how do you navigate those data sets, and do you sit and look at them and think, well, maybe too much of me is in here, too much of me is in what I've chosen, or how do you try and create noise in your own choices?
Well, at first I'm I don't have to create noise in my own choices, right? That's kind of the benefit of being an artist. I can do whatever. I'm not a hiring office that has to provide equal opportunity for everybody to appear in my art. So, but of course, it is an issue that, well, right now I'm a one-person band, I don't have the resources to go manually through 50,000 images and say, ooh, do I have the right balance of male to female faces? And actually, in this case, I want female faces, because if I train female and male faces together, you get this kind of, well, usually the male faces dominate somehow. So you get uglier faces, and but I have a male face model too. So but in the end, the data creates the bias. So if I randomly download faces from Tumblr, it's kind of like not my selection. It's kind of like, it's my selection in kind of which tags do I use. But let's say female face, then I might just get, I don't know, 10% Asian faces and 10% black faces. And it's, and in the end, at the point, I kind of focused specifically on certain faces in this aspect, because I didn't want to kind of create this multi-global thing. But you could counteract it if you wanted to. If you put work into it, it's no problem.
But then that becomes maybe problematic too. But I do think that this idea of the adversarial network and how it functions becomes an interesting metaphor as well, in terms of what is considered to be at odds and what is considered to be accepted. And as you say, in a data set from Tumblr, maybe only 10% of the faces there are Asian, and that could not, maybe 20% of the users of Tumblr are Asian, and we don't know how that plays out. So,
that's the cliche, but yes, all this kind of machine learning emphasizes the biases that are in society. Yeah. So yes, you actually have to actively counteract that. And if you are doing this for, let's say, professional purposes, you should. I think in art, you are free to decide if you want to do that or not. So in the end, if I want a certain aesthetic, I don't know, then I go for this, and then I'm white and male, and I prefer and not gay, so I prefer to see female faces, and so that's my personal decision, and I could.
I don't mean to focus too much on your own identity, but it's fascinating some of the language that gets used in terms of like collaborating with the network, or steering the data, or how the model inspires you, and you take these things out. And as an audience here who, and this is definitely my case, I learned a lot from how these things work from your talk. So I'm going to take the knowledge from here today and go out and be more aware of how these things are influencing larger questions. So there was the story recently of the Google image data that would recognize black people's faces as gorillas. And so they went back to the data and said, how do we deal with this? And the way they dealt with it is they just stopped the system from ever saying the word gorilla.
Yeah, well,
so they didn't go in and necessarily like solve the problem or whatever. But the problem is really complicated, and it's to do with the morality of these things. It's far more hard to steer and control and come into a relationship with than the data set.
Yeah, and these models make mistakes, and and some can be kind of remedied by kind of cleaning your data and trying to unbias it, but they will still make mistakes, and then and some mistakes are just not acceptable, and so in that case you just have to block it, I guess. So and sometimes that is the problem working with these neural networks. You never can get like 100% certainty that it will not do certain things, because they are so complex, and they are not based on they are based on probabilities, and so the question is like, do we have to learn not to blame the model too much? I mean, yes, you should blame the people who kind of irresponsibly deploy these models, but you just have to be aware that that you will never get 100% certainty and 100% quality, and well, that is kind of the price for their versatility and their powerfulness.
Because it becomes a kind of Socratic question in relation to what the software does and to release it to the world. Is it the responsibility of Google just to say, go out and mess around with this stuff? Or is it their responsibility to build into that system some kind of checks and moral frameworks that then mean that when it gets out there, it can, I mean, I'm asking you, but I'm also...
No. Well, the first thing is, of course, I do not speak for Google. Well,
yeah, of course.
I'm just artist in residence there. I know that kind of there is a lot of work going into this. So it's kind of, there's definitely something does not go out, like if there's a chance that it might fail, except for this mistake that happened some years ago, and then it was kind of fixed. But it's kind of, so there is really, like from my experience, there is actually responsibility, like these models are handled responsible. Yeah. But the thing is, like now it's kind of in the open, and everybody can train their models, and some people have less moral qualms to put these weird phrenology models out there, or gay detector, or all these things. And so, yeah, it's kind of like it's open source, so everybody can try it, and some people have no shame in trying to make their name with some controversial or useless crap science.
But maybe we can move on from this now, and I'm poking, and I don't mean to assign you the Google role, it's just that's where a lot of this, the people first saw these aesthetics and these tools. But
Deep Dream is kind of like non-controversial, I guess. Or do you see something
Yeah, because
there?
Dogs,
yes, dogs, everybody loves puppies, right?
But then that leads on to this idea of you called it the creep space, which I think is such a great term as well. There's all these terms coming out. This is also, again, my understanding of the adversarial network, that in some sense, sitting here and seeing these images, there's a sense of the uncanny. There's a sense of being confronted with your brain just wants to find meaning in this image.
Yes.
And some of them are so strong that even when you described it back to me, it was like, that's exactly what I saw. There's a woman leaning.
Well, that's the interesting part, that we actually, I have to make something where I ask people actually what they see, because I always wonder, does everybody see the same thing? I mean, that's these patterns. Well, the reason is like that they are creepy is that they are uncanny, is that they contain so many elements that you think you recognize and that kind of fit into your mental model, but then there's something not right. It's like, and that is, we look at somebody and there's just something not right, and that's kind of like our, I don't know, is that the reptile brain or something, but it's kind of like our self-protection mechanism, where we have just learned to judge certain things. And like, if it would be a comic figure or glitch, there's nothing to fear. But this is on the edge of real. So you look at it and think, does this bite me? And so I think that is why, because the model doesn't get it right, but it just gets it wrong on. Like if a face, for example, we are all face experts, so we know exactly what the right proportions, or kind of in which kind of span the correct proportions are, and the model doesn't get it right, so it automatically becomes creepy, because that is kind of what we feel like if something is off the norm. We get creeped out. And so beauty is kind of, or aesthetic or something well proportioned is kind of a very small space, and everything around it is creep, and then there's noise. But so especially if you're dealing with like fields where every human is an expert in, you are bound to end up in creep space.
Now this is really fascinating, and maybe, and I'm going to project, I'm going to anthropomorphize the systems that you're using now. It's very hard work for these systems to do this. As you say, a human, we have a big sort of 10% of our brain is just sitting there ready to recognize faces. That's all it does. And machines are terrible at this stuff. So you're almost putting the machines through torture here. You're like forcing them to do our bidding. Surely it'd be better if we did that work for them. They can like count our stocks and do all of the good things that machines do. How do you see these relationships developing this? And this is again this kind of adversarial.
Yeah, the adversarial principle goes through and through, and of course they will get better. And the beautiful thing about all these models is that unlike humans that cannot clone their brains, like if you make a child, you try to feed in everything you know and give it values, but then, you can just do it through those regular channels of communication. Or, these models, I can just copy a file and clone it and immediately have something that knows just as much as the other model, and then keep on training it. In a way, they are already reproducing on GitHub. And so that's why eventually they will get better and they will get less creepy. And
but that's only at one level, and I'm going back to the politics of this again. The data sets of culture are already implicitly biased. If you take any data set of art from the West, it's mainly men and women with their clothes off and white skin tone.
Yes.
And so the more these things like model and the more they get based on the same data sets, nothing changes in some sense.
But the thing is, of course, using the same models, you can also detect that bias. So you can actively, it's not that, you can at some point tell the model, this is wrong, or give me less of this. So in the end, using the models, you can also start debiasing that data or find where you have a lack of cultural data, or fields where you should add more, find more stuff. So in the end, the stuff that makes them bad is also what helps us make them better. So I think, the good thing is we are all aware of this bias now. I mean, many years ago, people just believed that statistics and whatever, I don't know, people with brown hairs are liars, or I don't know, okay, that is a made-up example, but and now we are aware of these facts, and so we can use the same models to counteract it. So in the end, I guess, and through this awareness, we will get better data, and so I don't see a future where this kind of confirmation bias, or I don't know what's it called, where it gets worse, but because there are still responsible people behind the data that will try to fight it. I mean,
so we're stumbling just as the machines stumble, and that's good because we learn as that process.
I mean, in some ways, I guess we learn through the machine that except for obvious things, that there is bias in our data.
Yeah.
I don't know that.
Well, the gorilla example is a complicated one.
Well, that is more of a. Well, that was complicated because I think it was some error in the model or some kind of failure in general. It was actually not a bias in the data. It was more something.
Well, as far as I understand it, the same models also tended to recognize white faces as seals or as puppies.
Exactly. There are all these
grab the headline.
Yeah, so that's what I mean about it's a general problem with the architecture, or in a way how the model kind of orders the world, kind of how this latent space is shaped. And in that case, you have the seals and the white faces there. And there is this border between them, which is, so ideally you are able to put the seals somewhere in the animal category, and then, or you separate, have a first model which is really just focusing on trying to separate humans from animals. So, but, we know about this now, right? So we can fix it. I'm always confident, at least when you know what the problem is, you can try to find a solution for it. So, and using neural networks probably will help doing that.
I mean, so maybe there's a way to move away from just images and vision in this now. And the way you're talking about the latent space, about what's expected, about the fact that the machines somehow, in highlighting our biases and how we navigate that latent space, how we tell the machine to cut it and cut through it, that we can then learn something new. And the best example of that was in Go, in the machines learning to play Go or learning to play chess. Once chess was closed, and this was not neural networks. But once chess became a closed thing for AI, people thought that was it. Chess was over. No one was going to be interested. What it's created is it's created whole new ways to play chess.
Yeah.
And the experts are now sitting down with the machines to train themselves. And they're working with machines to make new teams of hybrid, they call it centaur chess. And the Go players who've spent their whole life playing Go, they say that was the most beautiful Go move I've ever seen. And it was by a machine.
Yeah, no. So that is what I find, like, that's where my hope is, really, because ultimately I believe that human imagination is also limited. It's not unlimited. So we tend to think in certain patterns, which is why, I don't know, in 2,000 years of Go, people thought everything was found there and was already kind of there, certain ways how to play it correctly, and then you come with this machine and it opens you totally different doors and new views on that thing humans thought have solved. So
and we enter the latent space.
And we enter that latent, I don't even know if there's a latent space happening in that Go thing, but yes, so yeah, there's this kind of brute force, or in a way which it is, like of the machines, which are kind of so much like it's augmenting our own creativity and our own imagination using kind of capabilities we don't have, but at the same time, yeah, I see it as a co-evolution that will happen. Also, there's this thing about the problem being the machines could become super intelligent at some point, but that wouldn't help us because we wouldn't be able to keep up. So same with images or something else, the machine could generate an image which would be, I don't know, so far out, but we would not have yet developed the capability to read it, to understand it.
Or maybe it already does, we're not maybe.
Yeah, so maybe, I don't know, some of the that's the point. So I look through 10,000 images, and there's this one which maybe in 50 years would be a masterpiece, because by then people have developed the right understanding to read these images. Like, I don't know, glitch art. Let's go back to the glitch art. I don't know, let's say, would people have appreciated glitch art 50 years ago? I don't know. There's the same thing. You get educated.
Many people don't appreciate it now.
Oh, I do. I don't know. Okay, so it's still kind of this art. Okay, but I still think there is certain, you have to develop new ways of seeing and reading images, and so it is a slow process. Just the way. So the models can only evolve as fast as we evolve as humans. That's kind of what I'm thinking. So
okay, maybe we can leave our conversation at that and open to questions. Oh, please.
You. Oh,
lots of questions.
Thank
you. Hi. Can I? Well, thank you very much for the talk. Can I start by asking a really boring question about computing power?
Okay.
How much of an infrastructure have you had to build for yourself in order to do this kind of work?
Okay, no problem. So my computer is I don't know, in euros. My machine cost about 4,000 euros. So it contains 2 GPUs, two NVIDIA GTX 1080 Ti. This is kind of the model that currently is on the high consumer end, and actually right now these are in high demand because of damn Bitcoin. So at the moment it's kind of you have to have a dealer of your trust that still gives you is able to organize them. But so to start you need at least 1 GPU, which so in theory you could start doing machine learning for maybe £1,000 or so. I mean, you can start it with any computer, but it's no fun if you don't have a powerful GPU, because then it will use the CPU and it will be slow. So this is, actually I had a patron, a really nice person who donated me that machine. So
you weren't using your Lenovo?
No, well actually I started using this, but this is kind of this is kind of, well, actually, this still runs. I have this one bot which is called the Noveltist. I didn't mention it, but it's a bot that tries to find novelty in images, and it runs on that machine. There's this machine can run neural networks, but training them is painful. So for training, that's the long process. So you want as much GPU power as possible. But you can, of course, use cloud services. So if you just want to try, you go, I don't know, you can, there's Amazon, Google has something. Actually, there's something, you can currently do it for free. So there's this Google Colab. I mean, I'm not trying to make advertising for Google here, sorry. But this is actually a good tip because there are these IPython notebooks running on a Google Cloud server which can do machine learning. So they can actually connect to, so you can try this for free now because usually if you rent your own server, it's expensive. That's how I started. So, or you buy your own machine, which is also not that cheap.
Great, we've got another question over here.
Sorry.
Thank you very much. It was fascinating, really, really interesting and beautiful, or
you.
disturbing, either way.
Well,
But I wanted to ask you whether you had done any research on the potential, on potential copyright issues. Sorry
very
for this
interesting.
other boring question, but
No,
just
very
out of
interesting
curiosity.
question.
Thanks.
Well, so I can't really answer that. So right now, the way I see the models is like humans. So you go and in a, well, exhibition here, you look at a photo, you get inspired by it, and then you go out and take something that looks similar or is in a similar lighting or so. So in theory, I would say kind of the models, if you train them right, chop up what they learn in so small particles that, well, you would have to have a hard time to find out that original copyrighted image in there somewhere because it is kind of mingles with all the other images. So I'm pretty sure the lawyers are looking for ways to kind of like say, oh, you stole my image. But it's like, in a bit like music, right? Where they have these rules. I don't know, how many bars are you allowed to have in common? I think copyright is kind of outdated now. It's this kind of weird gradient there where it's, well, I don't know, copyright is like a threshold, right? Where you say, oh, okay, this is mine, but now it all flows together. So I don't have a good answer. Well, I would say if you do style transfer, then you are in copyright problems. Like if you take somebody else's photo and just apply some style, there I would be careful. And I mean, some of these things are on the edge where, I don't know, where I took some photographer's photo and kind of transformed it. That's why I tried to generate my own content, because in a way it goes down to the story of the image, or the basic skeleton of the image, which for me might be copyrightable, but then not. I don't have an answer. I hope nobody will find an answer for a long time.
Hello. I have a question about the future. So you showed us beautiful images, but rather than like trying to do style transfer or like a transformation of Mona Lisa, what if we could take Da Vinci's sketches? What if you could take sketches of machines, spreadsheets, diagram, and transform them to paintings of knowledge? Do you think that's possible, and how long will it take to do that?
So I see a sketch of a machine, and then the machine tries to analyze what's happening in the image and understand the structure and tries to build it. I think this will be possible. I mean, simple example is, for example, there are now these models where you do a sketch and then it makes a website from that. So it already tries to understand structures. There are models which can look at a photo and will tell you there is a boy with a ball sitting on top of a car. So these models get better and better in actually understanding what is happening in an image. So the path from there to trying to turn a sketch into something workable, possible, 5 years, 10 years maybe, I don't know. But I mean, you would probably train a very particular model on that purpose. That is kind of what's happening now. So you will not have this general artificial intelligence which just takes this sketch and then next it takes something else. So, but if you want to have a model that takes sketches and turns them into something, yeah, I don't think it's out of the question. It might be. Yeah, it would have to get some understanding of physics and kind of this general idea how the world works, but people are actually working on that, right? So there are these models where it looks at a photo and will tell, oh, the ball will drop off the table because it knows about gravity and certain positions. So, yeah.
Another urgent question
Oh, urgent.
Okay, thank you. And I'm intrigued by kind of broader possibilities opened by your project. But I also wanted to ask a deeper question around a certain framing of different forms of models, and especially the modeling, for example, of the idea of evolution that your project presupposes. And it seems to me from what you've been talking about that there is this notion of evolution as this kind of progressive, linear improvement. And I'm wondering, and obviously there are other theories of evolution, as evolution being just about zigzags and false starts and kind of going in this less direct trajectory. So I'm wondering to what extent your art has a certain kind of instrumental function of being, putting it unkindly, although I don't mean it because I'm fascinated by what you're doing, but in some sense a PR arm of Google, in the sense that you're still trying to show us what's possible within that and where things will be in 10 or 20 years' time. In the language you've used in relation to some of these was still quite instrumental, as in, well, it can be used to de-bias the data, or the data, it's not quite here yet, but in 50 years' time we might be able to do it. So we're all kind of moving upwards, that the data sets are moving, and I'm wondering about the bigger ambition of your art project and to what extent it's actually very much in alignment with the AI companies, with the Silicon Valley companies, and to what extent it would perhaps be possible and maybe needed in a way to think about art projects that kind of hack that kind of instrumental rationality proposed by that kind of AI research, and to what extent you actually incarnate and you are a kind of poster boy for that kind of...
Oh, God. Okay, first of all what you see is actually all my personal stuff, except for the X degrees, so Google would not like to be associated with creepy things, I think. And so this is so... And, well, I just happen to have this nice position where I can combine kind of like this getting data or working with data with this. But, okay, so, well, I would think well, I have hope in the open source movement in a way that if somebody wants to fight the system with their own weapons, it is already possible. And the adversarial principle is kind of what I believe in will prevail, that whatever you try, whatever, well, you can in a way try to fight anything by using this principle that evolutionary thing where you train something that again then tries to be better at it. So I don't know, let's say some company wants to track all our faces and get every data about you, then you try to train a model which manipulates your face in a way that the machine will not recognize you. And there are people who try to, like artists or activists, that try to put this knowledge out there or give people these tools at hand, but I guess it's at the moment, like the learning curve is too steep, that it's very much driven by Silicon Valley interests and nerds. So, but I believe that over time, as this awareness of these capabilities increases, people will find ways to like battle the man or how do you call it? But well. Evolution, you said. Like, okay, that was the other thing. So, and of course, it's not a straight line. And also these, like when you train these models, they end up in cul-de-sacs, and not every approach works. And I'm spreading out kind of in various directions because it's definitely not a straight line. It's more like a fungus growing, and here, and then this is a dead end, and then it's, well, you try a different way. So. I don't know if I can satisfy your question because yes, it's a. You also asked about kind of my personal future goal. I can tell you is to make myself redundant. Actually, so that is because I'm curious. So for me, it's more like, well, I happen to be in the position like to say, oh, what happens if I press this button? And so I want to actually make a model or train these models that in the end become their own entities, like my children in a way. And I set them free in the world, and they will multiply, and they will make every artist jobless or every photographer because they just make more interesting work than humans could ever do. I mean, I will never reach that point, but that is kind of my evil master plan in the end, that I just want to see if it's possible. So can they do something more interesting than I personally could ever do? And so what are the ways to achieve that? And of course, I will not get any support, so I have to figure out my own way. So.
Two questions here. I'm going to go behind the continuing.
So I'm quite interested in the notion of friction and seamlessness in technologies, particularly because if you mix it with this conversation that often historically happens around the neutrality of innovation and the neutrality of scientific discovery, I guess I'm kind of asking you a question, not making you again the burden for all AI people who are doing this work. But at what point is it the responsibility to provide or to add friction so that we don't end up with these kind of problems where it's not that we can't see it's made by a machine or not, but it's more the problems around the AI research recently about being able to identify faces that are partially covered by using things like GANs. I think it was through GANs. But I kind of want to hear your thoughts about whether it's actually your responsibility not to let it get to a point where we stop seeing it as being something which is created in this way. Actually, we should be inserting frictions in some ways to be able to help us identify it and to train it better.
I think it's very important. I just don't know how, what are examples, other examples of,
it's the Jurassic
adding
Park
friction to, previous systems where you do it just so, I wonder how that, I'm a practical person, so how would I introduce friction into the system by slowing down development,
I guess it's the whole Jurassic Park things of just because you can doesn't mean you should.
Oh, so I should, oh no, okay.
Yeah.
Unfortunately, I'm one of those irresponsible people who, if they can, they do it. So yeah, that is the thing. Of course, well, in a way, the only thing I can say, let's say I try to, by showing stuff I don't know, alternative phase, I try to make people aware of the capabilities of this technology, so everybody gets more critical in about how they perceive information in general. But I don't believe that things can be stopped once. I don't think that ideas can be stopped and somebody will do it. So maybe you just have to do it and kind of try to be one of the good ones and use it for good purposes, and maybe I don't know, let's say the bad things are this phrenology research. And so what we can do is, of course, just say, this is crap. Nobody should actually post about this or or write about this or take this in any way serious. So that is the only way I can see how to kind of keep this from happening again, that people who kind of oh, let's see if I can, I don't know, detect, I don't know what class you are by looking at your photos, and then you just publicize that people are doing this, and that is a bad thing. But people will try it, and you can just make it socially unacceptable. I mean, maybe I at some point become a villain because I'm dealing, I don't know how the tide might turn at some point. All this is kind of kind of a really nasty thing to do.
It all started here.
Yes. Yeah. No, it's possible. Maybe it's I don't know, let's say smoking. Okay, so maybe it's oh, you cannot do AI in here, go out on the street.
Thanks also for the talk. It was really fascinating. And I think, like Daniel said, it brings up, or it informs in a way that makes you then reconsider all of these questions that people are asking about. And I'm kind of interested in the way you describe teaching the algorithms, and I teach at university. And for me, the algorithms that you've got are the student who turns up and they've only looked at skate photography, so they believe that every photograph has to be taken with a fisheye lens, and then trying to work out what the next stages from that are. And the next stages are broadening the frame of reference, and then also trying to introduce things like how to produce meaning. So trying to think about ethics, politics, intention, representation, all of those kind of things. And I think in one way, the presentation that you've shown us raises all of those issues, because they're the issues that people are asking you about, and it does it quite effectively. But I was quite interested in how your excitement seemed to come from the aesthetic of certain outputs, because in a way, the most interesting thing in the neural networks in the production of these images is the negation of the aesthetic, and is more about the flow of the images and the way in which the algorithm understands things when bits are held back, because it can make us think about how we understand things when bits are held back, or when we have a bias. So in a way, the meaning of the work, if you see the work as the whole presentation, your work as the whole presentation, informing people, everything, has those fascinating things. but then almost the bit that you were saying is, but this is a great picture, and that seemed like I just wondered where where that came from, because you were going, they are seductive. I was also going, that's a great thing, but in a way, is that just to distract?
Okay, so
seduction?
my general motivation is really like trying to hack human perception. I mean, that is kind of what I'm interested in trying to make images appear like they have a certain aesthetic, or in a way this general adversarial approach to aesthetics in the general sense. So I kind of coming from this old 60s school where cybernetic aesthetics, where people first time tried to analyze can we measure aesthetics rationally? And so it kind of ended like in a dead end, but I pick up from there because they just didn't have the right tools. But I still believe in a way, I make make-believe art or make-believe pictures. So I'm really mostly interested in kind of the reaction a picture makes in your head, and treating really the pixels as the raw material. And like, if I just move them in the right places, then they will create meaning in your heads. And even though the machine didn't put it in there, that's kind of what I'm interested in. So I like this simulation of meaning. I'm kind of trying to hack the visual system with my images. I don't have a deeper, that is what I leave to humans. I just try, it's like, how far can I go that you can still believe it, or find something actually that was never in there, but it means something to you. That is where I'm hoping to go. Because I know it's definitely the machine doesn't know what it's doing. It's just kind of the right arrangement of shades and textures and things that suddenly make a picture appear in your head, or meaning. And this is the area where I'm interested in. And along the way, I start discovering the rules of aesthetics and general things that you learn in art school or photography school, but just because of, again, this feedback loop or my personal bias. Sure. Does that answer your question? Okay.
I realize that we're running out of time, and I know there's a load more questions, so I thought that maybe, given it's towards the end of the Q&A, people could air their questions all in one go. Here, if there were any remaining questions, and you could respond to them maybe as a
one word, yes, no questions?
Are there any other questions? I'm sure. So maybe you can ask your question, and then you can ask your question, and you can ask your question.
I try to answer
and
short.
Then and you can ask your question, and we'll hear the 4 questions, and you can respond. Yeah, great. Thank you.
I hope it's a quick question. The girl in front talked about copyright. I had a question written about copyright of your copyright. Who has the copyright, you or the machine?
Well, definitely I mean, right now, as you noted, right now, as I tried to get across, is the machine is really just a very, like a power brush, or like an instrument I play. So that would be asking if somebody plays a violin, but the violin makes the music, so it should get the copyright. So at the moment, it's definitely me. But that's the point. At some point, I hope to get to the point where that is actually in question.
Mario, we're going to ask you 3 questions in a row.
Oh, and then I should not answer them. Well.
Perhaps touching on the idea that somebody raised earlier about introducing friction. I was thinking it seems like the battle lines have been drawn up a bit between the image recognition community and the image perturbation community. And I was wondering, if you have been working at all with perturbed images or looking into that area, your thoughts.
Mm-hmm. And I should not answer that now. Oh, that's tough.
The question was about working between the image recognition community and their concerns and the image perturbation community. Did you have another question? And there was one question up here. No?
Yeah.
Yes?
Speak
into the microphone.
Thank you.
Press the button.
I have to press the button. Okay, as we're here at the Photographers Gallery, and there was some debate on the invention of the photographic apparatus, that it somehow destroyed something of the meaning of the production of images, whether the way they've been produced before. Do you think the work that you've been doing also somehow destroys something in the production of images that are happening now? And also, I'd like to say that you already have your evil logo for world domination with 2 horns on it.
Yeah. Oh, and are there any other final questions? No? Okay, do you want to speak to
Okay, so did I understand that correctly? Image perturbation? What was the second? Like there's restoration and? Preservation. Okay, so no.
Perturbation.
What is like? Oh, so I don't know about those battle lines. So there is kind of a conflict between people who want to preserve the images and other people who say you cannot change them?
No, it's more about image recognition, detection.
Oh, I see. Like the yes. And I forgot the question. Your question was if I
was just interested if that's something that you've been thinking about.
I mean, the problem with all of this is, of course, that it will be an ongoing battle. It's like the human immune system. So, yes, I mean, I don't know, your immune system managed now to battle whatever the Black Death or so. But then we get the next one. So it's the same with these adversarial networks. So, well, maybe we figure out a way how to kind of there's this word, okay, let's say perturb your face, but then of course then they build another network which will figure that out. So this will be going on. So in a way you have to find a way how to make that not happen in the first place, but this is of course something that would happen in politics, that you just say, no, we don't want any surveillance anymore. But I think in this country, this will not happen. So, or maybe you want surveillance and you, like in China, where people seem to be totally cool with it, which is even more horrible, that you say, like, okay, yes, I'm a good citizen and I will not do anything bad. I mean, that is kind of the Black Mirror kind of future where we supposedly... So in a way, in theory, I think I wouldn't bother with the face. You just have to figure out a way how to kind of like escape the system entirely. And I don't know how that works. So you have to make up this fake personality or something that, well, the problem is, okay, I can get there. So the problem is, of course, even if you try, like, conceal your face, you immediately are in the cluster of people who conceal their faces, which is even worse. So you actually have to find that ground where you're looking normal. So, yeah, I mean, now they're doing it with motion detection too. So, yes, I mean, ideally you have to go into politics and try to change the entire system. And of course that will not happen. So Mars, maybe? I don't know. Yeah, it's a horrible future. This is why I hope at some point I can just upload my brain to a digital world and then have not to deal with this anymore, because it will just get worse. I don't think it's right now. I don't see any. Actually, it's. Did you want to answer the
Yeah,
sorry. If I destroy anything. So, well, okay. Right now this is of course coming like a competitor in the game, in a way like photography became this competitor to paintings, and now, well, you don't need the camera. I think people will still be doing photography and doing their own thing. It's just a new thing, and in some ways it can inspire, or maybe like in the example of AlphaGo, it might actually inspire you to try similar things, like to add new ways of seeing or new ways of taking pictures. But of course, yes, this thing will make some things maybe superfluous or not needed anymore. But that is happening with technology in any field, right? I mean, I don't know how many typesetters are still around, or telefax repair companies. So this is just the way technology. So, but you will always find your niche where you still can survive, right? It just gets smaller and less comfortable maybe, and harder. Like less people can survive on that then. But if you have found something like a unique point of what you do and only you can do, then you will still be able to strive. And in the end, you have to figure out for yourself if you enjoy doing that or if you want to try something else. And of course, there's this whole kind of dealing, I don't know, like with images, like this attention economy war, where you look at your social feed and every image asks for you, look at me, and it doesn't matter if somebody took like, I don't know, 2 years to just get the right light and just get this thing, and it gets just as many likes as this stupid cat photo. So the question is, so in the end you have to make it up for yourself if you are still happy with that and what your values are, but in the end there's this attention war going on, and so of course, having neural networks where the single image doesn't really count. It's just kind of that it keeps being interesting all the time and steals your time, steals your eyeballs. So that is the nasty part.
Oh, well, thank you very, very, very much for your time, Mario. And thank you, Daniel, for the fascinating Q&A. And thank you for your wonderful questions. We're going to all head to the pub now, but if you want to ask Mario another question, I'm sure.
Well, at the pub, yes.
You're welcome.
Yes, absolutely. Yes.
Thanks very much, and hopefully see you at our Building a Feminist Internet Geekender in a couple of weeks. Okay, bye.
Thank you.